Okay, let's take a look at Pascal's triangle and the binomial coefficient. All right, so here's how we're going to create Pascal's triangle. We're going to start off with n equals 0. On that row, I'm going to make a 1. Then I'm going to move to n equals 1. And on that row, I'm going to make a 1 with a 1 beside it. All right? And here's how I'm going to make any subsequent row. The third row, which was where n actually equals 2, the third row, I'm going to place a 1, and then in every column, I'm going to look above that entry and to the left and add those two numbers to get the entry in this cell right here. So basically this is going to be 1 plus 1, which is 2. And the next one, there's nothing here, so I just add that 1 to get another 1 over here. All right? Now, when n is equal to 3, we're talking about the fourth row. I start with a 1, and then I add these two to get the entry that goes here, which is 3. I add these two to get the entry that goes here, which is also 3. And since there's nothing, 1 plus 0 is 1 for the last entry in this row. And then when n is equal to 4 now, this is the fifth row when n equals 4. So I'll start with a 1, then I'll add these two to get a 4. Then I'll add these two to get a 6. Then I'll add these two to get a 4. And then 1, finally. All right, then on the fifth row of Pascal's triangle, or the sixth row, which is where n is equal to 5, this is actually the sixth row of Pascal's triangle. We have 1. The sum of those two is 5. The sum of those two is 10. The sum of those two is also 10. And the sum of those two is 5, and then a 1. So on the sixth row of Pascal's triangle, we'll start with a 1. Then the sum of those two is 6. The sum of those two is 15. Sum of those two is 20. Sum of those two is once again 15. Sum of those two is 6. And then lastly, I have a 1. All right, let's do one more row. So this would be the eighth row, where n is equal to 7. So we'll have a 1. We'll have a 1 plus 6 is 7. We'll have a 6 plus 15 is 21. We'll have a 15 plus 20 is 35. Another 20 plus 15 gives me another 35. 15 plus 6 is 21. And 6 plus 1 is 7. And lastly, I get a 1. You could continue this forever and ever and ever. Now, what I want to look at is I want to look at the relationship between this and the binomial coefficient, okay? So the binomial coefficient is n choose I, and it's defined to be n factorial divided by n minus I factorial multiplied by I factorial. That's the definition of it, okay? Let's actually label these. Let's call this one here I equals 0. That's my first column. The second, oh, I equals 0 and I wrote 1. The second column, I'll call it I equals 1. Third column, I equals 2, and so forth. So this is 1, 2, or 0, 1, 2, 3 for I, 4 for I, 5 for I, 6 for I, 7 for I. So basically, I'm taking n and I across the top. N across, N down the side here, and I across the top. All right. So let me actually clean this up a little bit. Oops. Getting a little confusing here. All right, let me actually clean this up just a little bit here. I'm not going to write the I. I'm just going to write the numbers 0 to 7, okay? But these are values of I, but for space, I'm just going to leave off the I. This is 0, 1, 2, 3, 4, 5, 6, 7th column. Okay, so let's do some calculations. For instance, Let's say I want to calculate the binomial coefficient 5, choose, I don't know, 3. Well, that's equal to 5 factorial by its definition over 5 minus 3 factorial multiplied by 3 factorial. All right, so that's 5, choose 3. Let's see, 5 factorial is 5 times 4 times 3 factorial. That 3 factorial can cancel with the 3 factorial that's already in the denominator. 5 minus 3 is actually 2. So I have a 2 factorial and a 3 factorial, which this 3 factorial and this 3 factorial cancel out, leaving me 5 times 4, which is 20, over 2 times 1, which is 2. So that gives me 10. So it turns out that 5, choose 3 is the number 10. Well, let's see. If I go to the fifth or the sixth row where n is equal to 5, and I go over to 0, 1, to the third or fourth column here where I is equal to 3, I get the number 10. That's not a coincidence. That's not a coincidence, okay? Let's try another. Let's try another one. Let's try, uh, let's say 7, choose, I don't know, let's say 7, choose 2. 7, choose 2 by definition is 7 factorial over 7 minus 2 factorial multiplied by 2 factorial. That's by definition, okay? Let's see what this yields for us. We're going to get 7 factorial, which is 7 times 6 times 5 factorial. I stop at 5 factorial because 7 minus 2 is 5, and I have a 5 factorial in the denominator. Over here, I'll have 5 factorial times 2 factorial for the denominator, and just like I predicted, the 5 factorial cancels the 5 factorial, and we get 7 times 6 over 2 times 1, which is 2 factorial, right? Well, 2 actually goes into 6 3 times, so my final answer is just the product of 7 and 3. Well, 7 times 3 is 21. So I get that 7, choose 2 is the number 21. Well, let me see. If I go to the row where n is equal to 7, the 8th row, and I go over 0, 1, 2 for I get the number 21. Once again, that is no coincidence. That is that is a way that you can use to calculate the binomial coefficient. All right, let's just take a look at one more example. All right, let's say I wanted to do, for instance, let's say 9, choose 4. Well, we didn't do the 10th row, so we don't have anything where n is equal to 9. So we just have to trust that we're going to get the right number here. So we'll have 9 factorial divided by 9 minus 4 factorial multiplied by 4 factorial. Well, 9 minus 4 yeah, 9 minus 4 is equal to 5. So this is 9 factorial over 5 factorial times 4 factorial. And then we're just going to have to calculate all those factorials, okay? So let's see here. We have 9 factorial is 9 times 8 times 7 times 6 times 5 factorial divided by 5 factorial times 4 factorial. We can simplify. The 5 factorials would cancel out. Let's see. And let's expand that 4 factorial. So what I have on top is 9 times 8 times 7 times 6. And on the bottom, I have 4 times 3 times 2 times 1. Well, let's see here. The 4 and the 2 make an 8, so that cancels. And 3 goes into 6 twice. So what I'm really doing is 9 times 7 times 2. Well, 9 times 7 is what, 63? And 63 times 2 is 126. So if we went to Pascal's triangle and we went to the ninth row and we skipped all the way over to the fifth column, which is where I is equal to 4, that value would be 126. So that is the relationship between Pascal's triangle and the binomial coefficient.